Last one, final stretch, 1.5, classifying matter. So this one is the one that I think from like the beginning lessons is the hardest. So matter can be a pure substance, which means a form of matter with one type of particle. So pure, super uniform. That's how I think about it. So it can either be an element or a compound. So if a pure substance is an element, that means it's a unique substance that cannot be broken down in simpler substances through chemical processes. So it's like the kind of like basic unit of a pure substance. However, a compound is a pure substance that is a chemical combination of two plus elements in a fixed ratio. So, like, let's say you add like multiple different H2O molecules, that's a compound, but because all of the molecules are H2O, it's still a pure substance because it's one type of particle, versus an element would just be like a bunch of little hydrogen atoms. Okay, I hope that makes sense. And then in terms of elements, they can be monatomic, meaning that they can exist just as one atom. So like sulfur, you can have just one sulfur atom. However, diatomic elements, the Brinkelhoff family, those elements need to be there need to be two atoms within the substance. That's the only way that they can exist and be stable. So we have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And you do need to memorize this, but don't be too intimidated. Brinkelhoff, if you can like memorize that and then memorize letters in it, that's like you're good. Like that's pretty. I thought at least a pretty easy way to remember it. Okay, so an atom is the smallest unit of element that retains its chemical and physical properties. So this is just like, for example, one atom of, so like any monatomic element just means like there's one atom of it. So like one atom of like magnesium. And then the diatomic elements, there are two atoms of. Hope that makes sense. Okay, mixtures. So this is the physical combination of two or more pure substances. So they can be homogeneous or heterogeneous. Homogeneous is uniform composition. They look the same throughout, also known as a solution. And heterogeneous is composition varies. So you can see like differences with the naked eye. So some examples of that, let's see. Is it homogeneous or heterogeneous? Granite. So the things that are like if you think about granite, like counters in a kitchen. Okay? 3, 2, 1. That's heterogeneous. You can see like the little differences in granite. Like it's not all one thing. You can, see differences like with your naked eye. Next, air. This one, I don't know why, it would always trip me up. 3, 2, 1. Is this homogeneous? I don't know why I would think it wouldn't be, but if you look at the air, like you can't see differences. Like it all looks like one, like the same thing. Okay, homogeneous or heterogeneous salt water. Again, this could be like harder. Oh, I forgot to count. Sorry. This is homogeneous. Yeah, it looks like the same throughout. Like, yeah, you can probably maybe see like it's talking about it being dissolved. If it's not dissolved and you can see like the little individual specks of salt, then that would be heterogeneous. But this is assuming that like the salt is dissolved in the water and you can't see it. Okay, homogeneous or of. Okay, well, it says of. Heterogeneous. Homogeneous or heterogeneous. Jesus. Soil. 3, 2, 1. This is heterogeneous, so you can see like differences in soil, like the different textures of the individual pieces of dirt and like little tiny rocks. Like it's not uniform throughout. Okay, and some other vocab to know from this lesson. Molecule. Molecule is a particle that is made of two or more non-metallic atoms bonded together chemically. So, for example, H2O, hydrogen, not metallic, oxygen, not metallic. There's two or more. H2O, there's 3 atoms total, and they are bonded together, and they are a molecule. And then particle, any repeating or identically repeating unit of a substance. So you can see we use particle up here in the definition for molecule. Particle can be like a lot of different things. And what's really like important to remember is that when you're looking at a substance, it can be multiple things, and it usually is multiple things at the same time. Like it can be a particle and a pure substance and an element and diatomic all at the same time. You know what I mean? So I think we have some. Oh, first off, here's a important or helpful little chart when you're classifying matter. Which route to take and what that'll give you. And then here's last stretch. I think these are the last few slides. Okay, so we have this, I don't want to give any spoilers, but thing of sodium, Na. There's only one of them. So out of these, let me see, how many is this? 7 options. Which would it be? It can be multiple. Okay, so I would definitely pause this, think about it, think about the definitions for each and what makes sense. Okay, pause if you need time. 3, 2, 1. So this would be an atom, an element, a particle, and a pure substance. So it's an atom because it's the most basic substance of an element. There's only one of them, one atom. If there were 2 of them, then it wouldn't just be an atom, it would be an element, or it would be something else. It's an element because there's only sodium. There's no sodium and magnesium or chlorine or anything. It's just one. It's a particle because it's an identical or repeating unit of a substance. There's only one of them. And yeah, and pure substance, again, because it's kind of similar to the definition of particle. There's only sodium in this. There's nothing else. What could you call this thing? Okay. 3, 2, 1. So as a total, this is a mixture. You wouldn't necessarily, there are different parts, different things inside of it. Like there's molecules, compounds, but as a whole, since they're all different substances, it would be a mixture. Okay, and I think that's all for Unit 1, Lessons 1 to 5.